Hello, my name is Brandon Ojogho, and I'm a research assistant for the Laboratory of Functional MRI Technology at the Keck School of Medicine of the University of Southern California, and I'll be discussing our abstract titled The Evaluation of Cerebral Blood Flow and BBB Water Exchange in an Aged African American Cohort. I have nothing to declare. Cerebral small vessel disease is a very problematic disease. It is known to lead to dementia and stroke. Recent studies have shown that blood-brain barrier dysfunction is a contributor to the pathogenesis of cerebral small vessel disease by allowing for neurotoxins to access the brain and causing an ionic imbalance, as well as an inflammatory response around vessels, which eventually leads to the demyelination of white matter fibers. Ultimately, the goal of our study was to use a non-invasive MRI technique to concurrently measure cerebral blood flow, arterial transit time, and water exchange rate across the blood-brain barrier in an aged African American cohort. For our methods, 39 African American participants with an average age of 64, plus minus a standard deviation of 10.2 years, underwent an MRI on a Siemens 3T Prisma scanner for around 40 minutes. Neurocognitive assessments were performed, as well as a custom MATLAB toolbox to measure CBF, ATT, and KW in each participant. Also, public toolkits provided by the MARC BCID Consortium were used to calculate white matter hyperintensities, mean free water, and peak width of skeletonized mean diffusivity, respectively, in each participant. Linear regression models were applied to evaluate the associations of whole brain mean CBF, ATT, and KW with age, gender, CSVD biomarkers, and neurocognitive assessments using the NIH toolbox, respectively. For our results, CBF was shown to decrease with age. ATT showed an increase in age, but the association was found not to be significant. KW decreased with age, and CBF showed a positive correlation with high-density lipoprotein. When measuring LDH and triglyceride levels in the blood, both showed a negative correlation with KW. Both CBF and KW were significantly correlated with picture sequence memory test scores. CBF was negatively correlated with WMH, mean FW, and PSMD. However, these associations were not significant when age was included as a covariate in the regression model. Recent studies have also shown the trend of decreasing CBF and an increasing ATT with age. CBF is higher in females than in males and has been shown to be associated with gross cognitive function and executive function in a cohort of aged Latinx subjects. These findings have been replicated in a cohort of aged African American individuals who have high risk for CSVD. Our finding is also consistent with a recent study that reported positive associations of KW with CSF amyloid beta 42 and episodic memory score in a cohort of aged subjects with normal cognition. In addition, CBF was negatively correlated with existing CSVD imaging markers including WMH, FW, and PSMD, although age accounted for these correlations. To the best of our knowledge, this is the first time that DPP-Castle was applied in a cohort of aged African American individuals who bear high risk for CSVD. Our findings suggest the potential for CBF and KW as biomarkers of CSVD and may contribute to the understanding of the racial/ethnic disparities of CSVD. Our research on regional correlations is still ongoing as no concrete results have been found yet. Thank you, and this concludes our presentation.